Okay, so today we're going to be looking at the law of reflection. So in order to understand this, you need to first know about ripple tank. So this picture here is a ripple tank, and you need to know the structure of it. So this thing here, we call it a dipper. And there is also another one that is spherical shape, or sometimes we call it a point dipper. So when you place this dipper upward, then that means you are using this plane dipper, which is a straight line. Then it will produce a plane wave. When you place the spherical dipper down, then the vibration from this vibrator here will make the spherical move up and down, and therefore make a circular wave front. Okay, and then the structure of it is that you have this place where the dipper is over here, and then it is connected to a motor, and there's a lamp on top as well, because this lamp will show you this lamp will shine right through the wavefront over here, and then the reflection of it will be displayed at the bottom, which is we call the screen of it. But some of the new ripple tank will reflect this directly into a screen over here. Then you can see the shape of a plane wave over here, right? So inside here there will be water. So this is all water inside. So basically the wave that you're creating are transverse wave, which is water wave. And then there's one more part, a metal shaped stuff that we call a reflector. When you put it in, you can see various way how the wave will react in terms of their reflection. Okay, so that's all of it. And then the last one that we'll be looking at here is something that we call a stroboscope. So a stroboscope is very important for SPM syllabus, because you kind of need to know what it is and how to calculate and stuff. So the thing that you see here, we call this a mechanical stroboscope, but there are also other types of stroboscope as well. Other types such as light stroboscope. So let's just look at stroboscope first. This is mechanical stroboscope. So basically there are two discs here. So when you turn the disc around, as you watch the motion of the plane wave in the ripple tank just now, if the plane wave was at a frequency of, let's say, 5 hertz, which means there will be 5 plane wave created per second, and you were able to turn this disc 5 times in 1 second as well. So every time your eye, because your eye will only see through one of the hole here, so every time your eye see the plane wave, it will be at exactly the same place. So like right after every 5 wave has passed through. So then what you finally will be looking at is a wave that doesn't move, that looks still. Okay, and you also need to know in terms of calculation for this stroboscope by using this formula, F equal to NF prime, whereby N is the number of slit, F is the frequency of the water just now, and F prime is the frequency of the stroboscope. So frequency of how much the vibration from the dipper is, which is F. F prime is the number of turns that you get per second. Okay, so this is an example of a question for stroboscope. So they give you a water wave of frequency, of a certain value of frequency here. Then you need to be able to identify that this is whether this is F or F prime. So from the formula just now, we know that the frequency of the water is F, not F prime. Okay, and then they give you the number of slit, then this will be N. And they will ask you what is the frequency of the rotation of the stroboscope. Okay, so you just use the formula that we have just now, which is F equals to NF prime, and substitute the value that you have, 20 for F prime. Then when you work that out, you will get 5 hertz. Okay, so that's the example for the stroboscope question. So this is an example of a light stroboscope. So the frequency of the light is how many times it blinks per second. and the frequency of the string is how many it moves up and down per second. So if you were able to make the light blink the same time as the frequency as the string, then the string in this picture will appear to be stationary. This is other example of strobe light when you use it with droplets of water. So you can see the light blinking at the back there, okay, and then you can see this motion of the water droplets. So if the frequency of the light was made to move at the same time of how many droplets per second, then the droplet will appear as if stationary. And one of the famous scenes in movie was in Now You See Me Too, when Atlas was appear to control the rain. So now let's have a look at the whole law of reflection and the effects of it. So when a reflection happens, this is the effects that will happen towards wavelength, frequency, speed, velocity, and direction. Okay, so basically when reflection happened, nothing changed except for the direction. So the direction will change, and the rest will not change. But velocity is a vector quantity whereby you consider their direction. So that means velocity will change because the direction changed, not because the speed changes, because the speed doesn't change. Okay, so we'll also be looking at laws of reflection. So laws of reflection is very often asked in SPM questions. So you need to know the definition of it. And as soon as you know the definition of it, if you look at it from a picture, then you will be able to tell and answer the question based on it as well. So the law of reflection states that the angle of incidence, which is the angle here, where the light ray comes into the contact with the surface that's going to reflect it, is equal to the angle of reflection. So this here is the angle of reflection, where the light ray is moving away from the surface that is reflecting. Okay, and you also need to know that this incident wave, the reflected wave, and the normal must all be in the same plane. Okay, so here we're going to be looking at the types of waveforms that you are able to create in a ripple tank. So just now we talked about how to get a plane wave. So you need to use a plane dipper for that. Then your waveform will look like this. And in order to get a circular wave, then you need to use the spherical. Sometimes we also call it point dipper. Then the wave that you created, because the vibration comes from here, then the wave that you created will be a circular wave. And then just now is the reflector that is on the inside of the ripple tank. So you could have a plane reflector that look like this. So if your wave is coming in this direction, then when it hit this wave, then it will go back that direction. And same here, if the wave is coming in this direction, so your wave will go away in this direction. And then circular wave, you'll be able to see the effects as well, which I will discuss in the next video. Okay, so now we're going to have a look at a sample SPM question about this topic, which is question from paper 1. So you can read the question, try it out, and come back, pause the video and come back later for the answer. Okay, so in this question, it's already tell you that it is a reflection from a plane reflector. So you have to know that the speed of in the reflection doesn't change, the wavelength doesn't change, and the frequency also doesn't change. So now this question asks you which one of the statement is correct. So let's read one by one. So for A, it says that the speed of the reflected wave is the same as the speed of the incident wave. So this is correct. The wavelength of the reflected wave is shorter than the incident wave. This is incorrect because supposedly it wouldn't change. Frequency lower than the incident, also incorrect because it wouldn't change. So A is the correct answer here. Okay, so now for the summary, what we've looked at today is the structure of a ripple tank. So you kind of need to know how to create a plane wave and how to create a circular wave front, basically. And you also learn about stroboscope. For SPM syllabus, you don't really need to know about like stroboscope, so that's just extra things that I'm showing in today's video. So mostly mechanical, and you need to know in terms of its calculation. And then we have also looked at the law of reflection, which is angle of incident equal to angle of reflected, and some of the effects, all no change except direction. That's all for today's video. Thank you for watching.